All right, so what's your name, what's your role, where are you from?
Sergeant Jason English, Winnipeg Police Service, Winnipeg, Manitoba, Canada.
And so what are you thinking about this robot competition and how it might affect public safety operations down the line?
Yeah, these since my introduction to these, this is a really amazing place to be, get in front of the robotics that we use on the street every day, and to really have an influence on the development of the tools and tactics that we use, so that they can see it in the research lab instead of just coming up with the ideas on their own.
So you're having some interactions with the teams to help guide their research objectives?
Yeah, and this has been a really neat experience too, because public safety, we buy a commercial product and it's come to us polished and finished. So coming here and getting to see what the research and development side looks like first, where there's a lot of extra wires and a lot of extra cables, but to be able to influence what those things need to do and then clean them up into a package. And to see the real difference between the autonomy and the individual or teleop, the manipulations.
Yeah, so this competition is focused on the prototype stage, where robots are trying to learn how to be autonomous in rather complex terrains and tasks. Is there a terrain or a task that particularly speaks to your operational experience?
Yeah, one of the two that were kind of obvious here, you'll look around, or this video is going to highlight, this is a very accurate representation of some of the complexities that we deal with, but some of them that we don't. You take your average meth house, or you go in and there's clothing strewn about everywhere, and it's everything from hoodies and jeans to t-shirts or whatever, and that's a really complex underfoot task for the quadrupeds. And then the other one that we use in a manipulation world, real world, is what we call the blanket pull. It's finding the suspect hiding under the blanket or under a tarp or under a towel, or etc. So some manipulation to be able to pull that heavy and distance.
So this robot right here is fully autonomous right now and struggling his way through the ramp terrain. He gives up.
And cut.
So this is what the terrains are meant to do, to inspire some failure, see if it can recover. Have you, as an operator, ever flipped your robot on its back?
No, never, of course, yes. And that's one of the great things that I have with these conversations here, because when you go to manufacturers, they want to give you the polished version of what they do. It's tough. Here, these university folks in the lab, they're used to pushing it to failing every time to make it better. The one thing that's been really interesting to see as public safety, though, is how they troubleshoot by line and code versus just a user interface that we're used to. But yeah, it's really great pushing the limits. Back home, we train to failure, right? We don't train in combat. We don't want to do that in real world, but we train until we fail so that we can figure out how to not fail or less fail the next time.
So these competitions are about the development of the next generation of emerging tech, autonomy, dexterity, mapping, 3D, 2D. How do you see these test methods and maybe this circuit applying to training of personnel and remote operators?
This is the juice. This is why I joined this. When I first met you folks in NIST in 2019, I brought this back immediately to my program, drone-based initially and now legged, but this is what you need to do. Maintenance of competency on these leggeds. The one thing about public safety is we do a lot of it as operator initiated on purpose, right? Some of the autonomy, we don't want to be part of that. And so skill fade is huge, and dexterity, it takes a lot of time. Anybody can drive it in 5 seconds. It takes a real polished operator months to be able to replicate that over and over again, so that you can either improve your time or you can learn lines and angles and sort of feel the robot in a really controlled space.
Well, that's excellent. In your particular background, being a robot operator of legged systems and drone pilot, you understand the importance of teaming and multiple types of locomotion and ground with aerial.
For sure.
What can you say about the next generation of systems, autonomous or otherwise, that are going to need to be deployed in your public safety role?
Yeah, so the big one that we're starting to see fresh here is the rapid mapping piece. The LiDAR maps that these things are creating, they're downrange very, very quickly, and they're coming back, and you're getting to see it in 3D in absolutely no time. And then it is autonomous in that it can free the operator to go do operator-type things. So, and some of the, the edge detection and some of the AI building, if if we're putting sensors downrange as well, if you can just launch the sensor to go do gas analysis or whatever it is, and not every single thing that is autonomous allows the operator to go do really operator important things.
Yep. All right, one more shot at this. It's picking the hardest tile on the whole terrain. So the slip function is an advanced feature of these ramp terrains. The ramp terrains started flat, then they get inclined, and we add these slip discs. The idea is that one leg slips out, and the autonomy has to react quickly to compensate. And now this robot has a payload on its back, the manipulator, so it's a particularly challenging terrain for these guys. But if we were smart enough to take the outer loop, we would have a really better chance. This is where overlaying some remote judgment by the operator might be helpful.
Yeah, and that's
Overlay some steering commands. Okay, so this is the crux of the IEEE Robotics and Automation Society's Legged Robot Challenge happening here. A dozen teams or so can participate, and they perform something like 40 trials over the course of 3 days to fully evaluate the system across multiple terrains. In this case, 6 terrains. Just to get to this end to score points. Autonomous traversal scored. Damn, 1 point. You're supposed to do it 10 times in 5 minutes. So you think competitions like this are doing the right thing? Are they forcing the capabilities in your direction?
Yeah, and actually, I'd really like to see public safety participate in this, like as just an operator-only event, right? Just that would be the next step for us. But being part of the R&D and the development here is really great, and they really respect having the end user input. Just you don't have a meth house in a lab in the university, so it's really eye-opening for these guys.
Excellent. Any last thoughts you want to share with the committee or the public here?
Go NIST. I am such a fan. It's the standards they're agnostic to vendor. Oh my goodness. The NIST standards are agnostic to vendor. They're defendable. They're repeatable. We use them for pilot evaluations. I did or I did not. It's on the camera. It's a wonderful set of standards.
Excellent.
Yeah.
All right. Well, thank you very much.
You bet. Cheers.